First of all, I want you to remember this slide that Martina Schraudner showed with the ecosystem, where you have on one side you have the research and the knowledge, on the other side you have the potential markets for science knowledge, and in the middle you have the valley of death. So the reason we have to bring these two together and close the valley of death is basically because knowledge we have now is less good for women than it is for men. So I just have a few examples. One is here that actually biomarkers were mentioned. The top figure there shows different concentration of metabolites for women and men. There were 131 metabolites studied in this particular research. Over 100 were different concentrations. So when you validate biomarkers for metabolic diseases, for diagnosis, you have to have two types of biomarkers to start with. Okay? So if you needed to recognize someone who is at risk of diabetes, or maybe has got early onset of Alzheimer's, then you need to have the right biomarkers. The figure below, I'm sorry, they're looking a bit fuzzy, show immune response after vaccination for yellow fever. On the right are women. These are their signaling pathways. On the left are men. You can immediately see that these pathways are different. And at the top, it says that in the pink, that when the genes were expressed, so they measured the expression of the genes 2 to 10 days after the injection. In women, over 500 genes were expressed. In men, only 64. Okay? So we need to understand what is happening, because when studies look at the effects of vaccines, the undesirable effects of vaccines, when they put all the data together for women and men, they frequently say there's no undesirable responses. But when meta-analysis was done and the data was unpacked, they found that actually for women, the women have mounted much bigger immune response to vaccine than men, and hence really women need less vaccine, and the whole vaccination strategies have to be redesigned. So you have seen this here, so I'm not going to explain that, but let's just think why this is important, why we have to be concerned about the pain. We're not talking about headache. Last night I had a headache. I didn't bring any pills, but I could survive. But we're talking about real pain in cancer, in diabetes, in multiple sclerosis. As we're aging, there'll be many, many more people with the chronic, real serious pain. So we really need to develop not only the different kinds of painkillers for women and men, but also for different kinds of pains. And the animal, so there was a discussion about using male and female animals, but I think that has to be remembered that those animals are developed, those models of animals are developed for particular pains, okay? So we have the male rat, but even among the male rat models, there is a difference, okay? So when we're trying to understand the consequences of pain in humans, and the kind of pain I'm talking about, you cannot study in a laboratory because you could cause permanent damage to the human being, yes? So we also talked down in plenaries about crash test dummies, but the important thing is when you look at the real data out of accidents, and you look at the data that you get out of crash test dummies, there is not always a very good comparison, yes? They're not really matching. And that figure in the middle here shows areas of injury, particularly for women, yes, in a real car crash. So not only whiplash injury, but spinal cord injury. So what the anatomy and morphology of women is different. The vertebrates behave differently. When there's a car crash, three things happen. The car goes into the barrier, you inside go into the car, your brain and your organs go into the walls of your ring. The seat acts like a trampoline, so everything around jumps in your body, okay? That's where the problems are. So, and also how people use cars, women make a small drive, so it says there most of the injuries for women happen at between 20 and 65 kilometers. For men, at a higher speed because they're driving home to work at a faster rate. So these are the kind of things that need to be considered if we want to close the valley of death and have a better knowledge with which we match opportunities for science knowledge and the opportunities for applying knowledge. So General Motors has got 200 crash test dummies. They are all male of different sizes. Each one costs between $100,000 to $1 million to develop. They sell this technology to other car manufacturers. Okay? So everybody is using the same faulty technology. So we are in this valley of death, and as we saw from this presentation from China, yes, lots of very clever women coming into the pipeline and then dropping out, yes, for reasons that are not really supported to encourage, but they are there, okay? Let's just remember they are there. And so we would want to bring them into the innovation process, and there is a website called www.innocentive.com where companies that cannot solve scientific problems themselves, they broadcast this on this website. People can sign up as solvers. They earn money if they produce successful solution. There was a study at Harvard University to analyze solutions to 166 science challenges in which there were involved 12,000 scientists, but not all of them were in the formal system, i.e. not all of them were in universities or research labs. Some of them were outside. And the conclusion was that female solvers who were outside the outer circles would perform much better than anybody else. In fact, in general, people outside the formal circles produce better solutions than people inside, but women were particularly good at it. So what it means, we cannot think in the silos. We have to think like this, and hence the kind of approaches that Martina is doing with Fraunhofer. It's one way to achieve this. The other really very good example is how to tap into the intellectual and creative talent outside the formal circle is the gaming software called Foldit. It was designed to see whether you can use gaming to manipulate proteins and see how you can manipulate the structure. They tested it on a viral protein that scientists could not solve the structure of this protein for about 10 years. So, and this Foldit software is a bit like Tetris. So it's kind of a three-dimensional, and you pull and push, and this protein gets into shape. 57,000 people around the world went online and played this game and solved the problem within 10 days. Okay? So the only problem was for Nature is how you publish paper with the 57,000 names. The important thing is that 30% of those gamers were women. Okay? They were outside the formal circles, and they were producing really good contributions. So now we're talking about potential. One thing that is really bad for women is ionizing radiation. Of course, it's also bad for men, but it's much worse for women. Okay? Women get many more cancers from exposure to ionizing radiation than men. Men get more cancers out of sporadic cancers. Now, every time you go to the dentist, you probably get an X-ray of your mouth, or you get a CT scan, or so on. It is the prevalence of the use of ionizing radiation for medical diagnosis has been growing, and in America, people now experience 7 times more exposure to ionizing radiation due to medical uses than they did when the dosimetry models were developed. Yes, so the doses of radiation that are given now, are based on models developed like 40 years ago, when there was much less use of ionizing radiation, and was based on a male body, and hence reference men. Since then, of course, the use of radiology is very important, but the important thing also is that in a study that actually asked doctors how much radiation this person was exposed to, 93% of doctors thought that was much less than they were actually exposing the patient to. And the other thing about it is that young children are particularly sensitive to ionizing radiation, girls in particular, and this effect, so every time you have a little radiation, the effect is cumulative. Okay? So we need some better things to diagnose, obviously, something that is non-ionizing. And in Bristol University, they are using the principle that the dielectric constant in the breast tissue is the same as in the materials used for the landmine detection. So they have developed a system with 60 antennas that scan the breast, looking at the abnormalities in the dielectric constants to record, and within 8 seconds can produce a 3-dimensional image of the breast. So you can imagine this kind of, once it's now in the second stage of clinical testing, you can, every time you go to the doctor, you can lie down, have this done, and don't have to be exposed to unnecessary X-rays. And there was also mention of colorectal cancer. This cancer is under-diagnosed in women. This is because the kind of a standard method that is used by doctors called flexible sigmoidoscopy is designed, it does the, of course it's endoscopy, so it goes in, but it doesn't go as far as where the precancerous cells are occurring for women. So it's better for men than for women. So there was in Northwest University, they put a photonic light at the addition on the end of this sigmoidoscope and shines the light and measures the blood flow, an unusual blood flow in the colon. And then we have this very big issue. I am a sort of an advisor to a project that is developing environmental sensors to sense the water safety. Now, more women die from dirty water than men, obviously not in Korea, but in the developing world. And as the climate change will occur, temperatures will rise, more water actually that we will assume is safe is going to be unsafe. And then, people travel to the developing world, and 50% of them get a diarrhea. And this is not only just like one occurrence; there can be long-term consequences. And in the U.S., the cost per year is like 6.9 billion. So we need to think about, even in areas where technology has got really no sex, no gender, like those labs on the chip that are used in environmental sensors, there's nothing there, but the consequences of this technology are very important. So we also need to think about developing technologies that have a big impact on society. I don't know how many of you change your dish sponge for washing dishes, but a 10 centimeter square sponge contains 320 million bacteria. Okay, so there is also an opportunity for innovation here. So we need about sustainability. Sustainability is the big issue now. We have replaced Millennium Goals with sustainability development goals, and so on, and one of which is food security. Now you can increase yields of crops by just introducing more pollinators, i.e. mainly bees. Yes? 75% of the leading food crops, fruit, nuts, and so on, or 35% of the global food production is dependent on pollinators. Okay? So this, not only you improve the food production, but also the quality of it. And if we understand the chemical communication between the bees and the flowers and the behavior of the bees, for example, it seems that bees visit male flowers in the morning and female flowers in the evening, then we can enhance the interaction between the pollinators and the flowering plants. And of course, then women in the developing world can keep bees and have an extra income. Fish farming, one of the very fast-growing kinds of aquaculture and fish, sex comes into it because some fish in some species mature and grow in a different way in terms of females and males. So the turbot, the female grows in 50% bigger than the male. So if you have a farm of turbot, then you want to keep the females and you don't want to keep the males. In other fish that is common in the developing world, tilapia, it's the other way around. Yes? And then, of course, in Europe and in America, basically all the cod was fished out. So for a while, there was a moratorium on fishing cod. But now the cod started coming back, and people looked at the aging of the properties or aging qualities of male fish cod. And they found that actually old female cod produced very healthy eggs. So when you actually want to protect your fishing, you have to preserve the old fish, cod fish, and actually fish out the young ones, which is completely reverse to the current policy. Yes? So, and again, women are involved in fishing, so this is an important thing. So I'm just giving a few examples, but there are many. Yes? As soon as you start looking around, you can see many opportunities that when you have this knowledge, that this understanding the sex and gender differences is important, and we have data for it, and you understand that there are markets, you can bring these things together. So like the market is estimated to be 45 billion in 2020. So, conclusion, we cannot solve our problems with the same thinking we used when we created them. We need to think other ways, okay? We need to build the foundation of what we're actually talking about in this gender summit and the future gender summit, and we talk in the best. Basically, sex and gender interact, but they are in the environment, and so they respond to the environment and they influence the environment. We cannot just talk about one thing without also considering consequences of the others. And there are different kinds of innovations that we can look for. If we have the knowledge and we have already pre-existing markets, we can do this routine innovation by just making improvements. We can then go maybe more radical and maybe more disruptive or maybe more systematic and so on. So these are just examples what can be done. So you can find all the other information on this website.
All right, thank you very much. So the speakers, could you come forward to sit?
Thank you. My name is Jörg Müller. I'm coming from Spain, from the Open University in Barcelona. And first of all, thank you all the speakers for the very nice presentations. And I want to ask specifically Martina Schraudner, but all the others as well, about another aspect of gendering innovation systems and processes specifically. In my understanding, an innovation process always involves risks, it involves uncertainties, and this is often very costly. And my question is, to which degree is this specific risk management and uncertainty management gendered? And let me give you an example of what I mean. I did some research in schools in Barcelona, where there is, of course, introducing ICT into schools is a big issue, also in primary education, where most of the professors are women, like 70–80% of the teachers in primary education are women. And there's a very shortened understanding of what is involved in innovation in terms of you just drop in the latest technology, be it a computer, desktop, or an iPad, and then the innovation will happen. However, what this means for the professionals working in there, they really have to adapt and integrate the technology and make it work in the school. And this actually is a major effort that doesn't show up anywhere in the innovation equation for politics. It's not accounted for. So it's often the private time, their ambition, which makes this innovation work in schools. And I think something similar could maybe be happening in terms of robots, especially if they are introduced in the homes, where we should ask ourselves, well, what happens when the robot breaks down? Who cares for the robot? when the robot screws up, you know. Often this costs when technology fails is gendered. Well, the question would be, can you relate to this in other sectors than education or maybe in other home robots? Thank you.
So when computers were first introduced in the UK by Sinclair, you could actually get a kit. My son here, age 4, got this kit and actually constructed his own computer. I have friends who had girls, and they were all constructing their own computers. They plugged them to the TV, and they could do basic programming. Maybe that's the way to go with robots. You get a robot kit and then learn how to become an engineer by doing this kind of a robotics.
It's called Roberta. It's existing already. No, I think schools aren't a real market. The politicians had been the market where the computers were sold to. The next step to bring this into the schools is, I think, something different. And the understanding in the school, for sure, is it's a knowledge you have to have at the moment. And what will happen to the robots? So I think this is another definition of innovation. When you think about that, I think this question, what will happen in a household when the robot stops to work, when there are only elderly people around, which need this help, this may really become a completely different problem. And then you really need to think about all this organization around. And I think this is a case of responsible research and innovation, to think the whole chain before we have lots and lots of problems or dead people because of not working robots. So I think there is a need to involve the society much more than we do at the moment.
Well, we are facing a similar problem in autonomous driving. I mean, well, technology is a problem, of course, but we have other problems such as liability. When accident takes place, I mean, who will be responsible and who will pay for it? So we have the same problem with robots, I think. Well, I think we need some time, otherwise, I mean, it's not just technology can solve everything.
I have another small point. When you look at Uber, for example, this taxi system with the private drivers, it's overcoming the laws in Germany at the moment. And that's one of the reasons why they stopped it at the moment in Germany. And somehow I have the feeling when technology is too fast, then it will overrule and override all the societal rules at the moment. And this is a problem, that's true. And because technology is becoming even faster, this may be really a reason and a driving force for more responsible research and innovation.
But there's a very other example, very good one from India, where there was a well-meaning initiative to change the traditional cooking stove with a better design. They were designed in America, and they were tested, hopefully they were tested in the labs in America. They were introduced thousands of people, hundreds of thousands of people, and the study followed how it was accepted and what happened. In the installation of these stoves, men were not involved because men went out to the farm, not doing farming, and women were at home. So it was for women. It was not in the culture to train the women how to look after the stoves. Yes, the stoves were actually much more efficient in terms of burning fuel and also producing less pollution. But researchers found that after a little while, women stopped using them, because they didn't work, because they needed servicing, and so they went back to their old ways of cooking. Yes, so this is right from the very beginning. A well-meaning, well-funded initiative actually failed to produce the outcomes that were wanted.
So Elizabeth, you mentioned one example of what we would call citizen science. And is there evidence that you would see a stronger engagement in this case of a lower represented part of the population in, let's say, traditional science, and in that case, female researchers, citizen researchers? Is that the case, that there is, they don't see the barrier when they can actually do it in this citizen science way? I was thinking of this protein folding.
There's absolutely no problem for people participating in the folded. I mean, you can sign up as well. But basically, in that way, they bring into solving this problem different problem-solving abilities that obviously scientists in the lab who use traditional methods didn't have. But there is, when we had a gender summit in Africa last April, everybody in Africa has got a mobile phone. A mobile phone becomes also a kind of a citizen's can be lab equipment for monitoring the spread of diseases, for monitoring the health of the plants. You can photograph it with your iPhone, or have a, well, maybe not an iPhone, but anyway, you could use your mobile phone to communicate the information about your environment. So for disaster resilience, dealing with disasters, if you have women and men, of course, but they can collect and transfer the information so we can monitor the health of the environment in this way. This is really coming from the citizens. So they are kind of a human environmental sensors. They can go and collect information.
Well, thanks for the wonderful talks. But I'm just wondering, nobody was talking about this, the gender perspectives in database or machine learning. And could you some of you give us some insight how dealing with this? For example, the robot Pepper by Son Jung-hee. We heard that the robot could learn from the database while they're communicating, and it's going to the database, and then the robots, this Pepper learns from this communication. But then, whom he's talking to with like a gender perspectives in that learning, how one can distinguish or implement all these ideas. So it's just a curiosity from innocent.
Well, but that is my concern about what we say about robots. They cannot be like human beings, because human beings process information in different ways. We don't just process lots of data. We make interpretation of the data, and we select the data, which one we want, and so on. And we are full of cognitive biases. When robots have a cognitive biases embedded in them, they probably will be like human beings. But that's the big distinction. If robots can be solved by saying they can process a lot of information, but like they're in playing chess, yes? Nobody worries about playing against machine that is, and worries that it can win in chess, because you know it's really pattern recognition and lots of choices. That is not like human beings play. And I think there's an important distinction to convey to society. It's how robots actually make decisions. They are not going to be like humans. I was at Imperial College in the Department of Computing since 1980s, and we were talking of making an expert system that will do medical diagnosis. Well, I have not seen them in doctor surgeries.
Yeah, but just add one thing. According to the Kurt Wiles, I think is about the singularity, the book Singularity, he said that there will be a time will come soon that man cannot distinguish whether he's communicating with artificial intelligence or man himself. So that's all related, isn't it?
I know that companies working in this field are really seeking for women engineers and for women maths people, but we can deliver enough students at the moment, women students. So that's a problem in Germany, and I think not only. When I read the data correct, you have also the problems in math, in physics, in engineering, and yeah, the owner of the algorithm is the owner of the intelligence, in the artificial intelligence. Yeah, the system.
Well, in terms of the machine learning or the data analysis, I think there will be some way to figure out if this is the data from the women or the men, because the users anyways have to register their IDs in the system, so the system can figure out if the user is man or women. So based on the gender, I mean, maybe the system can accumulate the data, differentiating the gender difference, and based on the accumulated data, they can analyze the data. For example, if a woman say, I want to eat anything, it doesn't really mean anything, right? So when in the situation of the dating, so if this is the talk from the women, then the machine can analyze it in the different ways. So yeah, that's my opinion, personal opinion.
Well, we have, say, only 15 minutes till the dinner. So, well, maybe, I mean, we can continue. Oh, please, yes.
Yes, Gender Summit 6 is, Gender Summit 6 is holding in Asia Pacific region for the first time, where the research, the budget, R&D budget, R&D investment in the region overall is very low, except Japan, China, Korea, and maybe Singapore and Malaysia. Considering that Gender Summit should deal with such questions, such question as gender analysis should make some more contribution to cope with such enormous global challenges, especially in Asia Pacific, including environmental disaster, disease control, food safety, and overall well-being in everyday life for people. So, I mean, gender analysis should do something about coping with these challenges, these urgent problems we are facing. So we should deal with more on the social development, on the contribution of gender analysis in terms of social development. I'd like to hear some more from Dr. Pollitzer.
Well, I completely agree with you. Yes, this is just emerging. This is just emerging knowledge. So the Stanford database has only existed for, I don't know, 4 years. our understanding, I continuously sit and look for new studies to collect examples of research that has been done that included sex or gender analysis, even though people didn't go with that idea that it was not, it was just very good methodology that they used. I think we have to put this knowledge, to start putting this knowledge together, because at present it's scattered all over the place. And Jörg Müller there is the coordinator of a project in Europe that is building a portal of quality information, just like that. So researchers, practitioners can go and find, at least start finding really good resources and add new resources. But that's in English, yes, most of it. And I think such database, such portals would have to be developed in other countries, because whether researchers in those countries are working and publish in the language of the country. Martina always tells me that a lot of research in Germany is just published in German. So these are the kind of issues. And then focus on areas which are of real primary importance. Yes, well-being, health, food security, and so on. And start accumulating first examples of research that has been done, so it's in one place, it's easily accessible, and can be used for training. And then developing case studies, such as started being done in Stanford by Alonda Schebinger, because we need more of it. I mean, if you're doing new research project, but you are an experienced researcher, you can go to Stanford database and learn a lot and analyze it. But if you are a young researcher, you might actually need some help in trying to understand what it all means. So we have to look at it as the beginning of a process of a new knowledge. Yes, a new knowledge that's going to improve the methodologies in science in different fields. So we need to understand sex and gender analysis, typically for different problems. And then we also need similar thing, just for the process of innovation. But as far as I can see, we are just at the beginning of it. And hopefully by the time Horizon 2020 will finish, we will have quite a lot of, at least identify good places where the good information exists.
I can offer an example which is gender related, but I don't know how you could solve this problem. Because during the big Wenfan earthquake in China, which happened in the night, you find that the casualties were mostly women, because in the middle of the night, you know, when something unusual happened, the men could dash out in their underpants, but the women had to put on some clothing. So that was the crucial few seconds. But I don't know, this is not related to your innovation or anything, and I don't know how this problem can be solved.
Well, maybe it's more than that, I think, yes. It may be related to physical, say, strengths and others, so yeah, maybe.
Oh, yeah.
I mean,
Yes, of course.
Not just the adequate clothing.
No, because they had to have time to put on the clothing.
Yeah, right. Mm-hmm.
Yes.
Well, okay, we have only 10 minutes left before the dinner. So maybe we can continue discussion over the dinner. And thank you, speakers, for a wonderful presentation. And thank you all for coming and participating. Yeah, thank you very much.